Hi everyone, today we will talk about Newton's second law of motion. We will describe what the law is and calculate problems related to it.
Now, since we will be talking about second law of motion, we will connect it first to the first law of motion. So connecting the first and second law of motion. So who can write the first law of motion? An object in motion stays in motion, an object at rest stay at rest, or an object will stay in place. If there is no net force on an object, there will be no acceleration. Very good. So that is what the first law states. An object will stay at rest, an object will stay in motion unless acted upon by unbalanced force. And when your unbalanced force is acted upon, then there will be acceleration. So if you will connect it to the first law, our second law is law of acceleration. And law of acceleration came into existence because of unbalanced force. So when you applied an unbalanced force to an object that is at rest, then there will be acceleration. So the acceleration of an object is the result of an unbalanced force. So if the object undergoes two forces, the motion of the object is determined by the net force. So meaning to say, let's say there is a ball. The ball is at rest. When you kick it, you will apply an unbalanced force. And the result of that, because you applied an unbalanced force, the ball will keep on moving. And when the ball is moving, then there would be acceleration. So that's why they are connected to each other. So with that, our second law is known as law of acceleration. First law is law of inertia. Once you applied an unbalanced force, law of acceleration will take place. So they are connected. So I want you to remember that in dealing with law of acceleration, there are other variables included. So you have acceleration, you have force, and you have mass. So the magnitude of the acceleration here is directly proportional to the magnitude of the balanced force. That is the relationship. So when we say again directly proportional, what happens to acceleration happens to force. So when acceleration is greater, that means the unbalanced force that you applied to the object is also greater or higher. If you applied small and balanced force, acceleration will also be smaller. On the other hand, the magnitude of the acceleration is inversely proportional to mass. So what happens is if the object is heavy, if the object has a higher mass, acceleration will be lower. So they're opposite. If the object had a smaller mass, acceleration will be higher. For example, let's draw a scenario here. Let's say there's a box and your box has, let's say, weight. This one weighs 10 kilogram. And then you pushed it, so you applied a force. So let's say you applied a force of 10 Newton. Will the acceleration be higher or lower compared to your letter B? Your letter B scenario, you have also a box, but this one is bigger. So it's heavier, 20 kilogram. And then you have 10 Newton of force. And of course, you will apply 10 Newton of force. Will the acceleration be higher or smaller? Which one do you think will have a higher acceleration? Scenario A or scenario B? Your answer is letter A. The reason for that, it will have higher acceleration because the mass is lower as compared to B. So meaning, in order for your B to have the same acceleration with A, you need to apply how much force for B in order for them to have equal acceleration? How much force B needs to have? 20. Very good. So 20 Newton of force in order for it to have more acceleration. So now that we know the relationships between mass, force, and acceleration, let's go over now with the second law, because your second law revolves around those three. So the relationship are stated in Newton's second law of motion states that, so you have to memorize this one. This is law of acceleration. The acceleration of an object is directly proportional to the net force on the object and inversely proportional to the mass of the object. And that can be written in an equation form. So it's like a formula. It will be stated as A equals F over M. So A is your acceleration, and then when the variable is on the numerator, that represents directly proportional. And then if the variable is on the denominator, that represents inversely proportional. So when you take a look at the formula, A is directly proportional to F, inversely proportional to M. Now, since we have three variables, when you have three variables, that also means that you will be having three formulas or three equations also. Okay, so here. So in order for you to find out the equation, you can draw a triangle and then you divide it into three and then you set it up this way. Your F will be on top. This force is the main thing in the law of motion. Your M is here and your A is here. Now, let's say, for example, you need to find out for the A. You will just cover the A and then copy whatever variable stays. So A equals F over M. So you copy it the way how it looks like. So it's F over M. If M is missing, you cover M and then you copy the way it is, F over A. And then if F is missing, they're beside each other. So F equals M times A. So you have three formulas that you can use. So the next thing that you need to remember is the units. So according to Newton's second law, a net force on an object causes it to accelerate. However, the larger the mass, the smaller the acceleration will be. So we say that the more massive object have, it will have a greater inertia, which resists acceleration. So the unit for force are defined by the equations for Newton's second law. Suppose we wish to express the force that will give a 1 kilogram object an acceleration of 1 meter per second squared. So F equals to MA, you have 1 kilogram times 1 meter per second squared. That's 1 kilogram meter per second squared. The unit kilogram meter per second squared, or the combination of units for mass and acceleration, is Newton. So Newton is the unit of force. So they shorten it into Newton. It's a derived unit for force. So usually for law of acceleration or second law of motion, you can explain it through calculations or problem solving. So it's going to be easier for you because you already know the formula. So we have here an example on solving for force from a word problem. So the problem that we have here, very short. What force is required to accelerate a 2,000 kilogram car at 2 meter per second squared? So of course, we will still be using the format that we're using already. And first, we will underline key informations like the given 2,000 kilogram, 2 meter per second, and as well as the missing variable, force. Next, you go through the steps. First, identifying and labeling the given information. You have here G for given. So for you to memorize, identifying what is required, R for required, rewrite the formula, that's another R, and then substitute and solve for double S. So you have to fill in the informations. Given 2,000 kilogram for mass, 2 meter per second squared for acceleration. Required, or what you are asking for, is force. Write the formula for force, that's mass times acceleration. Substitute the given number, so that's 2,000 times 2, 2,000 for mass, and 2 for acceleration. You'll have 4,000 kilogram meter per second squared, or shorten it to 4,000 Newton. Okay? So that's how simple it is. One, you will be doing it. So I will turn on your pen. I want you to write the given required formula and then solve for it. F equals your M, 2 kilogram, times your A, which is 4 meters per second squared. So your answer is 8. What is the unit for force? So the unit for force, of course, is big letter N. So F is 8 Newton. So that's how you solve for force. So now using the format that you've learned already, can you solve for it? If a 45 kilogram person and a 15 kilogram sled is pushed with a force of 300 Newton, what will be the person's acceleration? Okay, first, can you underline the given number and then the missing variable? So 45 kilogram, 15 kilogram, 300 Newton. And what is required? What do we need to solve? You have your kilogram, you have your Newton, you have your mass and force. So we need to solve for acceleration. Now, there's 2 kilograms here. What are we going to do with this one? Add or subtract? For the kilograms. Okay, we will add them because as you can see on the problem, the person is on the sled. So you will combine them. 15 plus 45 is 60. So what is the formula? What formula are you going to use now? Okay, A equals force divided by M. So your force is, which one is your force here? 300. So 300 divided by 45 plus 15, 60. 300 divided by 60, what's the answer? Okay, 5. 5 is the answer. 300 divided by 60 is 5. What is the unit for acceleration? Okay, meter per second squared. There should be an S. Okay, S squared, meter per second squared. So that is your acceleration. Okay, good job, everyone. That's quick. And it seems that you know already what to do. So let's
Thank you so much for watching. I hope you learned something today. See you next time. Bye.